To Math 1324. This is section 4.3 on Gauss-Jordan elimination. So let's talk about some basics first. Let's say that I have this system of two equations and two unknowns. The unknowns are x and y. I'm trying to find an x and a y that solve both of them. So the first thing that we do is we make this into the augmented matrix. How do I do that? Well, I grab the coefficients, the 1, the 3, the 2, the -1, and the 0. The place where the equals is where this vertical line is. Now, we then will take the augmented matrix and we'd like to transform it. Now we're going to transform it using row operations, and the hope is I can take it and transform it into something that looks like this. It has ones down the main diagonal, zeros in the other places, and I'm going to get the answer for x and the answer for y. And then that would tell me that my system of equations has one solution. But during the process of transformation, we might get a situation where we have something, 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 and then 0, 0, and something not 0. And that's important, is we get zeros and something not 0. In that case, what that will tell us is our system has no solution. Now, that's another possibility. We may also get the situation where I get something, 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 and then a whole row. The whole row all the way across are all zeros. And if that happens, then that says our system has an infinite number of solutions. So again, there's three things that could happen when we try to transform. I might get ones and the answer for x and y, or I might get 0, 0, and something not 0, or a whole row of zeros. Those are the only three things that can happen. Now, what would that look like? Well, I might get something that looks like 1, 2, 5, and then 0, 0, 3. So that's the case where I have something not 0, but zeros all on the left. That would be no solution. And if we get all zeros all the way across, then that means we have an infinite number of solutions. All right, let's go back to our example. I want to use this 1 to make a 0 under it. Well, why? Well, remember, I'm trying to get ones here and zeros in the other places. So we're going to work left to right, use the 1 to make a 0. Now don't worry about those other numbers. Just ask yourself, what would you multiply by 1 so that when you add it to 2, you make a 0? So what that means is I'm going to take -2 times this whole row. So -2, -2, -6. And that's what you see here, -2 times row 1. Here's row 2. All right, there it is. I'm going to add these two together and make a new row 2. Let's see, these add to give me 0. -2 plus a -1 is a -3. And -6 and 0 is a -6. So here is my new row 2. So I do have a 1 and a 0. I now need a 1. Now we usually make ones by either multiplying or dividing. Okay, so I'm going to take row 2 here, and I'm going to divide it by -3. So that would be 0, 1, because -3 divided by -3 is 1. And then -6 divided by -3 is a 2. All right, so let's see where we're at. I've got a 1, I've got a 0, I have a 1. I now want to use this 1 to make a 0 above it. So I simply multiply this row by -1 and add it. So here's -1 times row 2. 0, -1, -2. All right. Here's row 1. I'm going to add them together to make a new row 1. 0 and 1, 1. -1 and 1, 0. -2, add 3. I get a 1. And so our matrix has transformed into one that looks like ones down the diagonal, zeros in other places. So the answer for x is 1 and the answer for y is 2. So the general plan is get a 1 first. Use the 1 to make a 0 second. Get a 1. Use the 1 to make a 0 last. And hopefully we'll get the answer for x and the answer for y on the right. If our system is bigger, how does the plan change? We hope to get a 1, use the 1 to make 2 zeros. Then go to column 2 here. I want to get a 1, use the 1 to make some zeros. And finally, third, use this one to make 2 zeros above it, and then hopefully that gives me the answer for x, y, and z. So the general plan is to use ones to make zeros. All right, in question 1 here, they have the matrix. It's an augmented matrix, so what they want us to do is rewrite this back with x's and y's. So here's row 1. That's 1x minus 5x2. See, they're not calling it x and y. They're calling it x1 and x2. Equals, so the vertical line is equals 4. 4x1, 6x2 equals 1. Minus 1x1, 4x2 equals 7. So they just wanted us here to take the augmented matrix and write it back as a series of equations. All right, in question 2, we have a large system of equations here. We have an x1, an x2, and an x3. So I take this system and I write it as my augmented matrix. I'm looking for a 1 there. I don't have one, but there is a 1 in this position. All right, so I'm going to take row 3 here, and I'm going to swap it with row 1. That does not affect my answers in any way. The answers will still appear where they're supposed to. So I'm just going to take this row, put it on the top row, and write it there. Next, I'm going to use this 1 to make some zeros. So if I take -2 and add it to 2, that would be 0. If I take -3, add it to 3, that would be a 0. So let's see, -2 times row 1, all the way across. So -2, -10, 22, -14. So here's row 2. Just rewrite it, add them up. All right, and this will become my new row 2. Okay, I repeat the process to get rid of the 3. Minus 3 all the way across. Let's see, minus 3, minus 15, 33, and a minus 21. Here's row 3, just write it down, add them up, and I get my new row 3. So let's put all that back into our matrix and see where we're at. All right, well, let's see. I do have a 1. I do have 2 zeros. I'd like a 1 there, but, well, I can't get a 1 there easily because if I divide this row by 8, it doesn't go nicely into minus 18 and 22. So I would be left with ugly fractions. So we have to be cunning and devious here. I'm just going to use the 8 like it is because I know I want a 0 under it. So I'm going to take row 2 and just add it to row 3 because that will make the 0 I need. Okay, so here's row 2. Here's row 3. Add them up. Okay, that looks pretty good. So here's my new row 3. So at that point, let's see, what can I do? I'd like to make a 0 here. All right. First off, I can take row 3 and divide by a negative 1 because that'll clear away these minuses. So take row 3, divide that by negative 1, and I get 0, 0, 1, and 1. Now, while I can't divide this row by 8, maybe I could make the numbers a little smaller. So I'm going to take the whole row and divide it by 2. I guess that'll make the numbers smaller. So 0, 4, minus 9, and 11. All right, let's see what that does for me. All right, that looks not too bad here. 0 here, 1, numbers are a little smaller. Now, I still need a 0 there. That's where we have to be a little bit cunning and devious. I'm going to use the 4 and the 5 just like they are. So I'm going to take minus 5 times this row. All right, minus 5 times row 2. And I'm going to take 4 times row 1. Okay, now why would that work? Let's see. Well, 4 times a minus 5 is a minus 20. And 5 times 4 is a positive 20. And so when I add them up, I would get a 0. So that's why I'm doing it. So let's do that now. Multiply by minus 5, multiply by 4, add them up, and I get a new row 1. Okay, so let's see. Now you might say, but wait, I thought we had to get 1s on the diagonal. Yes, but we can postpone it until the end. That way we avoid having to add fractions at every step. Alright, so now I do have a 1 here, and I'm going to use the 1 to make some zeros. So let's see, if I take minus 1 times this row, add it to row 1, I will make a 0 there. Okay, so here's minus 1 times row 3. Here's row 1. Add them up. Okay. I can take 9 times 1 and add it to that minus 9, and that'll make that a 0. So let's see, there's 9 times row 3. Add that to row 2. Here's my new row 2. All right. So let's take a look. Well, that looks pretty good. I've got lots of zeros. Got a 1. The only thing left is these are not 1s. Well, now it doesn't matter if we made fractions. I'm just going to divide row 1 by 4 and row 2 by 4. And when I do that, I get 1, 0, 0, minus 7, 0, 1, 0, and a 5. Making my item look like what we need. Ones down the main diagonal, zeros in the other places, and I get my answers for each of my variables. Now in this case, they named them x1, x2, and x3, and so we'll label them that way as well. And so those are the answers that would solve all three equations all at the same time. And then the conclusion is there is one solution, and it is minus 7, 5, and 1. Just be very careful on these problems. It's easy to make a simple adding or multiplying mistake, and then that's very difficult to find. You almost have to redo the problem to find your error. So go slowly, go carefully. I know you can do it.